I'm now moving on to page 245 in your workbook, and on page 245 I need to use L'Hopital's rule to evaluate the following limit problems. Now when you're using L'Hopital's rule, you always need to do a direct substitution first, and if you ever get a limit in the form of 0 over 0 or infinity over infinity, then you can use L'Hopital's rule. Alright, so let's take a look at question number 1. So for question number 1, step 1 is you want to do a direct substitution with 2 for all your x values. And if you do that, you should get 0 over 0. So once you get 0 over 0, that's a good sign where you can use L'Hopital's rule. And for L'Hopital's rule, you just need to take the derivative of the numerator and divide by the derivative of the denominator and then do a direct substitution step. Alright, so let's take a look at the numerator here. What's the derivative of that? Alright, well the 3 would come into the front, that's a power rule, so 3 times x minus 1, and then the power rule states that the power goes down by 1, so that's going to be a 2. And then the chain rule states that you need to take the derivative of the inside, and the derivative of that inside, x minus 1, well that derivative is just 1. And then the derivative of minus 1 is just 0, so that's it for your numerator. Divided by, then what's the derivative of the denominator? Well, the derivative of x minus 2 is just 1. Alright, so now you've taken the derivative of the numerator and the derivative of the denominator. Alright, after that, you can now do a direct substitution step where all the x values now get replaced with 2, and that would give you a result of 3 times 2 minus 1 squared all over 1. Sorry, the pen's not working here, and that would give me a result of 3 times 1 divided by 1, and that answer there will simply be 3. So my answer for question number 1 is 3. So L'Hopital's rule is a very quick way to evaluate limits if you get 0 over 0 or infinity over infinity when you do a direct substitution at the start. And then you just keep on taking the derivative and do a direct substitution step, and that should give you your final answer. Okay, let's take a look at question number 2 here. And once again for question number 2, if you do substitute 1 in right away as direct substitution, you would get 0 on the numerator and 0 on the denominator. So this is a good sign that you should be using L'Hopital's rule. Now before you do L'Hopital's rule, you might want to rewrite the numerator, that part right there, the radical into a power, so that should be x plus 3 to the power of 1/2, and then minus the 2, all divided by x squared minus 1. Once you've rewritten the original problem like that, now you can go ahead and take the derivative of the numerator. And for the derivative, the 1/2 would come in front. So that would now be 1/2 times x plus 3 to the power of negative 1/2. And then the derivative of the inside of x plus 3 is just 1. And then the derivative of negative 2 is just 0. So that's it for the derivative on the numerator. Divided by, now what's the derivative on the denominator here? Well, the derivative of x squared minus 1 is simply going to be 2x. That's the derivative, and then you write your limit sign out in front, the limit as x approaches 1. And now you can do a direct substitution step here and just simplify your answer. Okay, so let's do that. If I take my 1 and plug it in for all my x values, I would now get 1/2 times 1 plus 3 to the power of negative 1/2, all divided by, well, 2 times 1 is just 2. So I can just write my answer like that. And after that, you just need to simplify this. So if I take this 1/2 and that 2 on the denominator, that's going to be 4 on the denominator there. And this part right here, I mean, that's the same thing as, well, 1 plus 3 is 4. So this is 4 to the power of negative 1/2. And that's simply going to be 1 over 4. 1 over root 4, sorry. Let me just erase this again, apologize for that. This part right here, that's the same thing as 1 over root 4. And then you still have this red 4 hanging around. And if you do that, that should be 1 over, well, root 4 is 2 times 4 is going to be 8. 8 on the denominator, so this should be 1 over 8. So my final answer there is 1 over 8. So I do apologize for that little mistake there. So this part in blue here is that part there in blue, and just multiply the results and you should get 1 over 8. Okay, moving on to the next question, question number 3. And once again, if you plug in 0 right away for your direct substitution, you do get 0 over 0, which is which is undefined, and that means that you can right away go into L'Hopital's rule by taking the derivative of the numerator. So the derivative of sine 2x is cos 2x. And then the chain rule states that you need to take the derivative of the inside guy, and the derivative of 2x is 2. And then you would divide that by, well, what is the derivative of tan 5x? Well, the derivative of tan x would be secant squared. So secant squared 5x. And then you take the derivative of 5x, which is simply going to be 5. And then you write your limit statement at the front, the limit as x goes to 0. Okay, so after that, now you can do a direct substitution step. So the 0 can now go into here, and for that value of x, so this would be cos of 0 times 2 over secant squared of 0 times 5. And well, cos of 0, if you think about the graph here, here's the graph of cos theta. And cos of 0 has a value of there of 1. So this guy right here will simply be 1 because the height here is 1. And then the 2 would remain divided by, well, now you have to evaluate secant squared of 0. Let me just do that calculation on the side here. Secant squared of 0 is the same thing as 1 over cos squared of 0, which is the same thing as 1 over cos of 0 times cos of 0. And if you go ahead and evaluate these guys, those guys are just 1, so that's the same thing as 1 times 1 times 1, which equals to 1. So what that means is secant squared of 0 is simply going to be 1, and then you times that by the 5, and the 1's cancel off, and now you have just 2 over 5, so the final answer here is just 2 over 5. And that's your final answer for that limit problem. Okay, let's move on to the next one, question number 5. And once again, if you plug in 0 for h at the beginning, you would get 1 minus 1 over 0, which is the same thing as 0 over 0. So this means you can use L'Hopital's rule because you have 0 over 0. All right, let's go ahead and take the derivative now. The derivative of the numerator here, 2 to the power of e to the power of 2h. Well, the derivative of that will be e to the power of 2h times the derivative of the power, which is just 2. And then the derivative of negative 1 is just 0, so that's it for the numerator there. And then the derivative of the denominator here, the derivative of h is just 1. So this will be the limit as h goes to 0. And then you can go ahead and do a direct substitution step here. So plug in 0 for h there. So that would be e to the power of 0 times 2 all over 1. E to the power of 0 there is just 1 times 2 divided by 1, and the 1's will cancel, and your final answer here should simply just be 2 then. So 2 is your final answer for that particular problem. Okay, let's keep on going along here. Question number 7, another limit problem where t goes to 0, and if you plug in 0 for t's here, and if you work out the math there, you once again get 0 over 0. So once again, we need to use L'Hopital's rule and take the derivative of the numerator and the derivative of the denominator. I'll start off with my limit sign there. Okay, what's the derivative of ln of t plus 4? Well, that derivative will be 1 over t plus 4. And then the derivative of the inside here, the derivative of t plus 4 is just 1. So if you want to times that by 1, you can. This right here is a constant. So the derivative of constant is just 0. And then the derivative of negative t is just minus 1. All divided by the bottom, well, the derivative of t is just 1 there. So that one was pretty simple. And then what you really just have is 1 over t plus 4 minus 1, cleaning that up. And this will be the limit as t goes to 0 there. Okay, so that's what you would get once you clean up the algebra there. And then after that, just plug in 0 for t. And if you do that, you should now get 1 over 0 plus 4. And then you would have a... Oh, just one sec, sorry here. If I just erase this it's actually a plus 1 here, so that should be a plus 1 and a plus 1. So sorry, I do apologize for that one. That one's a plus 1 there. So if I finish out the limit problem here, it would be 1 over 0 plus 4 plus 1, which is the same thing as 1 over 4 plus, well, 1 is the same thing as 4 over 4, so this would be just 5 over 4 is the final answer. Great. All right, one more problem to go, and then we're done the L'Hopital problems here. And for this one here, if I go ahead and plug in infinity for the x values, I would get infinity over infinity. So that's another indicator where I can use L'Hopital's rule. And we just need to take the derivative of the numerator here and the denominator. The derivative of ln x is 1 over x, divided by the derivative of x is just 1. And this is the limit as x approaches infinity. And if I now go ahead and plug infinity for x here, that would be 1 over infinity over 1, which is just 1 over infinity. And 1 over infinity is just equal to 0. Okay, and that concludes all the homework problems for L'Hopital's rule. And we'll see you in the next homework video.